Good afternoon and welcome to the Site of Wetland Scientists June 2020 webinar titled Roadside Right-of-Way, Wetlands Resulting from Road Construction and Mowing Practices and presented by Edward D. Insminger. My name is Roy Mastaros and I'm pleased to moderate this webinar and engage you in an e-learning experience with SWS during a time when many of you are sequestered at home. This is our way of staying connected to the wetland community during the global pandemic, and we hope all of you are well. Next slide. For those of you who may not be familiar with our SWS webinar series, all of our monthly webinars are complimentary SWS members and are usually held on the third Thursday of the month. Once each quarter, we open up our webinars and offer them free to non-members and the public. As you can see on the listing of our upcoming webinars, we have both our regular SWS webinar series in English and also have quarterly webinars offered in Spanish. Our next free webinar, quarterly webinar, will be held in July 2020 and will be presented by our 2019 Wetland Ambassador, Priyanka Sakar from Assam University, India, and her mentor, Elizabeth Watson from Drexel University in Pennsylvania. We are proud to announce our first two SWS webinar sponsors, which are Water Resources, Hydrology, and Hydraulic Engineering Education. That's a Facebook page, which I would encourage you to visit and like. It is about a nonprofit organization that's sharing wetland water resources, hydrology, and hydrologic engineering to help educate our world. The second is Wetland Group, which is a natural resources consulting firm that balances regulatory compliance with sound ecological management. You can find their information at the websites listed above. We are proud to announce our next two SWS webinar series sponsors, which are In Situ, Monitoring Equipment and Software Works together to make it easier and more cost-effective to collect, access, and manage water levels, water quality, and water flow and more. And our fourth sponsor is WildNote, which is a field data collection app for environmental professionals and streamlines the process of collecting, managing, and reporting environmental data so you can work smarter, not harder. You can find their information at the websites listed above. We're happy to announce that this webinar has been, we are happy to announce that this webinar may be approved by SWS Professional Certification Program as applicable for continuing education credits. So just to clarify, we're waiting to get the approval. These credits can be applied to professional wetland scientist certification renewal or other certifications. Participation credits are available through the automated process. You will receive an email from our SWS Managing Director, Michelle Kosek, about 1 day after the webinar. Check your spam email if you don't see it. These certificates are free to SWS members and are available to non-members for a nominal cost of $20. Participation certificates are also available to those who watch webinar recordings, which can be found on our past webinars page or your YouTube channel. Before we get started, I'd like to go over a few housekeeping items. The general format for today's webinar will be a 45-minute presentation by our presenter, followed by approximately 15 minutes of questions. You participants are all going to be muted. For question and answers to ask, you would ask them in the question and answer pane shown here. Jordan, who's our support, will check the chat, also upvoting. Anytime during the presentation, you can type your questions into the question and answer pane. Handouts, PDFs for this website may be sent out in one-day reminder. And don't forget about tweeting hashtag SWS webinar so you can tell people about the experience today. Advance, please. There we go. Thank you. It is my pleasure to introduce our speaker today, Edward D. Insminger. Mr. Insminger earned 3 Associate of Applied Science degrees in Fish and Wildlife Management, Fish Management and Aquaculture, and Parks and Recreation and Wildlife Management from Hooking College in 2007 and 2009. He received a Bachelor of Science degree in Wildlife and Fish Conservation and Management from the University of Rio Grande. In 2009, a Master of Science in Wildlife, Fisheries, and Aquaculture Science from Mississippi State University in 2014. His master's thesis was on the plant community response to reduced mowing regimes and occurrence of white-tailed deer and other wildlife observations along highway right-of-ways in northern Mississippi. Since graduation, he was hired as a full-time research associate in the Department of Sustainable Bioproducts, Forest, and Wildlife Research Center at MSU. In 2015, he obtained 3 professional certificates as Associate Wildlife Biologist, Associate Fisheries Professional, and a Wetland Professional in Training. He is a wildlife and fisheries biologist and general ecologist. His research has focused on prairies, reclamation sites, forested environments, wetlands, mowing on roadside right-of-ways, and habitat structure. He has over 12 years of education experience and over 15 years of work experience in the natural resources profession. Excuse me. He has been with the university for over 10 years and recently promoted to Research Associate 2 in August 2018. Currently, he is working towards his PhD in forest resources at Mississippi State University. He has co-authored and authored more than 10 professional peer-reviewed research articles, a thesis, 1 book chapter, several technical articles, more than 25 popular articles, and currently has more than 3 journal articles in peer review process. With that, I will hand over control to Edward and welcome you. Thank you.
Thank you, Roy. I greatly appreciate the opportunity to come and be a part of the Society of Wetland Scientists webinar series. Sorry about that. With this, basically, appreciate all the introductions and everything that you've done to kind of get this ball rolling. So with that, we'll kind of go on to some background information about roadside maintenance within the United States. Back in the 1950s, roadside right-of-ways were repeatedly mowed and used herbicide treatments very heavily to basically look like golf courses. By the 1965, the Highway Beautification Act through the Lady Bird Johnson Wildflower Center was established, mainly to look for the visual, aesthetic, and even ecological qualities to help improve these right-of-ways that have been so heavily mowed. By the 1970s, Harper and Lohr and even Harper and Lohr and Wilson found that DOT's, Department of Transportation's, needed to seek alternatives to reduce any kind of cost, whether it's maintenance costs, mowing costs, mainly because of the high fuel prices that were going on back then. By the mid-1970s, the U.S. Department of Transportation basically worked with Lady Bird Johnson Wildflower Center to help establish a beautiful wildflower program throughout the United States. Some other justification, by the early 1990s, kind of still talking about some background information about the roadsides. The Federal Highway Administration and the U.S. Department of Transportation recognized a nationwide trend towards a conservation approach of roadsides and even roadside right-of-way ditches. And what I mean by a roadside or a roadside right-of-way is basically basically right where the blacktop ends on the side of the road, all the way down to the ditch, and all the way even to either a private property or to a forest line. That is what is considered a roadside right-of-way, just to kind of get things in perspective. Right-of-ways have typically been managed with intensive mowing regimes, multiple mowings throughout the growing season, 3, 4, 5, 6, 7 times throughout the growing season that these right-of-ways have been mowed in the past. Heavy herbicide practices have also been done for reducing invasive exotics and any kind of other non-native species, mainly vegetation species. As you can see, it's also very expensive to do all this stuff. If you're out there and you have 10 or 12 mowing crews on one highway, and you're putting herbicide down, and you're doing it multiple times a year, that gets very, very expensive. There's also urban development that can occur also along the right-of-way. And then it can also be an agronomic turf grass business as well. Right-of-ways also pose a big problem because they introduce and they spread non-native, exotic, and even invasive species. And some of these terms like non-native, exotic, and invasive species or introduced species, some of these I'm going to kind of potentially interchange, but mostly they're about the same wording overall, and they have a very similar type meaning. So talking about like roadside wetlands, since this is what the topic is all about, over the past many years, I'm sure people have been seeing these roadside ditches kind of morphing into what can be considered like strips of wetlands. This is mainly because of road development, reduced mowing practices that have been started to be implemented across the United States and other parts of North America, bridges and culverts that have been put in or even modified and in more recent years updated. All this has kind of constructed these, what I consider roadside wetlands. The construction of roads basically have created functional wetlands or wetland environment that might potentially even be governed by the wetland regulation. Greenfield et al. In 2005, as well as Armstrong et al. 2017, they both found that mowing and road development greatly affects the soil composition, the groundwater, as well as the surface hydrology, and what mostly I'll be talking about is the vegetation composition. This is kind of just a picture of what I'm kind of referring to when I say these roadside strips or roadside ditches, roadside wetlands. To the far left is where the road is at, and then you can kind of see a culvert down the picture a little ways, and really that area where it's in a swale or in that ditch area. Roadside have lots of disturbances. We've mentioned a few of them so far. Yager et al. In 2007 found that introduced plant species, these non-native plant species that I mentioned, they thrive with repeated mowing, multiple mows per year that also bare ground. Whenever mowers or construction goes on along the highways, they're going to be tearing up the ground and disturbing that soil. Anytime ditches need to be redug to have better water flow, that also is a disturbance along the roadsides as well. And then anytime a bridge is needing to be updated or constructed, this also causes disturbance that could introduce any kind of plant species, and that's where a lot of invasive species are thriving. Just to kind of show you a few invasive plant species that we particularly deal with here in the southeast of the United States. Johnson grass is a really big problem, Invasive grass as well. Chinese privet, that's been a big problem across the whole United States. Bahia grass, which is a turf grass, it kind of got out of turf management and now it's along our roadsides. Kogon grass, that's a terrible weed that's been very difficult to control. Kudzu, as well as Lesbedeza clover, and both of those are legumes. They're nitrogen fixing plants, but they're definitely causing a lot of problems. And there's a whole lot more, but these were just a few that we are particularly having problems with here in the southeast. Just to kind of give you an idea, there's well over 3,700 invasive plant species in North America alone. If you want to talk about like animals and reptiles and things like that, that number drastically increases to well over 5,000 invasive mammal species and insect species and stuff like that in North America. But I'm mainly focusing on the vegetation aspect. these invasive plants and these invasive species, they cost on the magnitude of $120 billion per year to help control them, to help reduce their impact, to try to basically eliminate them from a native environment. And there's several different research citations there at the bottom that have been instrumental of calculating the billions of dollars that these invasive plants are causing worldwide. Some other additional problems with these invasive plants, Young and Clausen found that a lot of it's with the loss of native plant communities. You have reduced wildlife habitat, and so a lot of native wildlife won't use a lot of this invasive plants. They're just not adapted for it. They just maybe less food available for it, less cover, less breeding opportunities, and so they just don't typically use a lot of this invasive plant areas. This also limits the native biological diversity that we have, not only along our roadsides, but just worldwide. The native diversity has been reduced so much that there's some places that are just so sensitive areas there that only some certain species are only living there. And then also, we've already mentioned before, is it's a high economic cost. We're talking billions and billions of dollars to try to remedy the invasive plant costs. There's definitely a decline in native grasses and wildflowers, specifically along the roadside right-of-ways, but this is also all throughout the world in many cases. So we came up with a project, me and some co-workers came up with a project about how can we beautify or change up the quality of the roadside right-of-ways. And also kind of asking a question like what native grasses, what native forbs, wildflowers, and even wetland plants might be able to come back in when we reduce our mowing schedules. Go from like a 7 times mowing the right-of-ways down to maybe 1 or 2. And so that's kind of the thought process of this research that I'm going to share with you guys today. Several studies have already shown that native grasses and wildflowers and even wetland genera are coming back and that are prevalent along the highways, but we just wanted to find out how much. And so there's different grass species like andropogon, asclepias being your milkweeds, your carex and your cyperus, your sedges, your helianthus, your sunflowers, your lyrasia, another grass, liatris and rudbeckia, as well as even your cattails, your typha genus, sagittaria, and even salix being a tree. But a lot of these are wetland indicators and they live in wetland environments. Another good thing about doing some of this research and some of the literature is that some of these and most of these grass species and most of these wildflower species and even wetland species are less palatable to white-tailed deer and other larger ungulates, other type of like deer and big mammals. And so that can come into a big effect, specifically since we're talking about roadsides. You're driving down the highway, here you have an opportunity to not only see beautiful roadsides, but that could potentially pose a problem for like deer or smaller mammals or something to come to the roadside and have vehicle collisions. And we can talk a little bit about that, but mainly we're focusing on the vegetation and improving habitat for along the right-of-ways. A good positive thing that we've also found is that a lot of these species naturally occur. The seed is already there, it's already established in the soil along the roadsides. And so by reducing the mowing, we found that, you know, they're naturally coming back. So the purpose of the research was to evaluate the plant community characteristics in different mowing regimens along highway right-of-ways, specifically in Northeast Mississippi in the United States. I had 10 research plots that I studied in 2 different counties within Mississippi. The top county is Oktibbeha County, and then the second one that I also researched a little bit of is in Winston County. It was along a major highway called Mississippi Highway 25. It is a 4-lane highway, and it's got a divided median in it. And I have a picture in one of the next couple slides that kind of shows a little bit of the breakdown of what the highway kind of looks like. Some of the research objectives that we compared was species richness, percent coverage, so how much area a specific species was taking up, as well as the percent coverage within different height categories. We wanted to see certain species don't get as high as others, and so we also kind of wanted to look at if repeated mowing is causing those plants to grow taller or keeping them short. And so we kind of added this factor in there of different height categories. Less than 0.46 meters, so about less than 18 inches, between 18 inches and 36 inches, so 0.46 meters to 0.91 meters, and then anything above that height category of 0.91 meters in height, so greater than 36 inches, greater than 3 feet in height, to kind of share different metric units with you guys. We also looked at the woody plant stem density, and we did that based off of a stems per hectare while I was collecting the data. We also looked at native and non-native invasive plants, their status categories, as well as 3 different treatment categories. There's a mowed category where the highway and the research plot was continually mowed 3, 4, 5, 6 times in the growing season. A second treatment was a reduced mode treatment where it was only mowed once a year. And then the third treatment was reduced mode only 1 time per year with supplemental wildflower seeding. We also looked at upland sites versus like a lowland riparian sites as well. These lowland sites or these riparian sites were influenced by overbank, inundation by streams, by nearby streams, and even the right-of-way drainage ditches. Then obviously we had to consider seasons and even your year effect as parameters as well. So a lot of information that we had to collect and a lot of information to kind of analyze. Our field methodology used vegetation line transects from both Hayes et al. And Buckland et al. Basically, the upland site here on the screen, you can kind of see that you're going up a hill. And so just kind of sampling the data along that line itself. The lowland sites, they were in areas where flooding was always prevalent, and this site in particular, I had many trail cameras that had water that showed this site completely underwater for months on end during the growing season and the wet season. But usually the lowland sites were flat, and they had the bridges nearby, as well as a nearby stream or even a large river in some cases. There's another kind of picture of an upland hillside. Basically, I started at the very bottom of the ditch and went all the way up and sampled the vegetation. The lowland sites, once again, here's a little bit better picture of a lowland site. You have a drainage ditch on the left-hand side of the picture, as well as there's an actual stream or a creek running under the road, and that's why the bridge was formed. But I'm really looking at the vegetation all around this whole area in comparison to seeing what's out there. This diagram kind of shows what our plot setup was what it looked like. Each plot was about 100 feet by 100 feet, or 30.4 meters by 30.48 meters square. I did the line transects in the very middle of each subplot just to help avoid any kind of edge effects influences. So if a mower accidentally got a little too close, then that right there would not skew the data or skew any of the results. briefly mentioned these before, but just to kind of show you on the screen, there were 3 treatments, and we randomized them into each subplots. Greater than 3 times per mowing annually was one subplot, 1 mowing annually during November, and then 1 mowing annually during November with native supplemental seeding, wildflower seedings. These field parameters, just wanted to kind of refresh you on them. Within each subplot, I took species richness. I did a percent coverage. I did the percent coverage within 3 different height categories, as mentioned before. Less than 0.46 meters, between 0.46 meters and 0.91 meters, and then anything greater than 0.91 meters in height was recorded. And then we also looked at the woody plant stem density using a belt transect, which was established about 1/2 meter to the right of each line transect throughout the study. The seasons were spring and fall season, the elevation, upland and lowland, and then there was also a year effect throughout the 2-year study that was conducted. A lot of statistical analyses was put into all this vegetation data. If anybody's ever collected vegetation data, there's a lot of work to be done. The percent coverage vegetation data, we broke it down between native and non-native species. And then also we broke it down between the growth form categories. Your forbs, your grasses, your legumes, your rushes, your sedges, your shrubs, your trees, and your woody vines. And then I have an other category in there. If there was something that maybe fit in several categories or just didn't have quite a category that we selected, maybe I put that in the other category. I tested for differences in percent coverage among the treatments, elevations, seasons, and even years. And by doing this, I used a program called Program R. It's a non-parametric multivariate analysis of variance is what I used. And within Program R, I used the vegan package and mainly used Adonis. I also used another statistical analysis program called SAS. And I used that to cover the rest of the data that was collected, the species richness, the percent coverage within the 3 different height categories, and the woody stem densities. I used a mixed model, univariate repeated measures, analysis of variant, the proc mixed coding for that. And every single piece of statistical analysis was tested at the significant level at alpha level less than 0.05. And that's both for the SAS data that I use as well as the Program R. So to kind of get into some of the results and some of the cool, interesting work that was found, there was over 277 plant species that was recorded along the highways. About almost 80% of those species were native, and about 22% of those species were non-native. And I went back through, and all close to 1/3, about 33% were wetland indicator species. You can see the forbs, they had the largest amount of species that was detected, whereas the rushes and sedges and shrubs and trees and the woody vines, they were also very numerous in the native category. The non-natives, they had some of the highest in the grasses and the legume category. And we'll talk a little bit more about why those are more significant in just a few minutes. The species richness, this is kind of a chart of all the breakdown between the seasons, the years, the 3 different treatments, the elevations, native and non-native. And also along the top, we've also combined native and non-native as one, just to see if there might have been any differences whatsoever. And at the alpha level of 0.05, we found that years was significant among the native and non-native groups, and as well as elevation. Elevation was also highly significant. There was differences there. One thing that stood out was that treatments, the 3 different treatments, had no differences whatsoever, no statistical differences, which basically is saying that the 3 treatments were very similar in their vegetation composition, specifically in the species richness category. Kind of a breakdown of the numbers. I won't elaborate too much on much more of this, but you can see in the lowland category, I've got this broke down between the seasons, like fall and spring, and then also based off of the years, 2010, 2011, 2012, the native status, and then the non-native status, and between upland and lowland. The lowland category, the Lowland Site, produced the most native species. That's highlighted here in red. Also for the upland, once again, the native status produced the most species richness, mainly in the reduced mode and the reduced mode seeded plots. On the other hand, the non-native status of different species, of plant species, they produce the highest amount in both the lowland mode as well as the mode upland areas. Once again, this is going to be quite important for talking about percent coverage, but it's just talking about the species richness numbers. The lowland areas and the natives have everything beat, and they're in really good shape. Now let's talk a little bit about the percent coverage results. Combining all the percent coverage and kind of doing a comparison between years, season, and treatment and elevations, we found that years, seasons, as well as elevation, the differences between elevations and seasons and years were all significant. Once again, we didn't find any differences, statistical differences among our treatments whatsoever. Here, this figure shows, it may be a little confusing, but on the left-hand side, we have the vegetation percent coverage going from 0 to 100%. And along the bottom, I have it broke down between mode, which is the M, the RM is the reduced mode treatment, and then the RMS is the reduced mode with supplemental seeding treatment. As well as on the bottom, we have it broke down between the fall and the spring seasons, as well as the years, and between lowlands and uplands. The 2 colors that are shown on the screen, the blue represents non-native agronomic grasses, and I've hand-selected the top 7 that I pulled out for this figure, which were Bermuda grass, tall fescue, Bahia grass, Vasey's grass, yellow foxtail, field brome, and even Johnson grass. Those were the only 7 that I compared to all the rest of the basically 270 remaining vegetation parameters, the species and everything else. And as you can see, for the most part, it didn't matter if it was in the mode plot or the reduced mode plot, or even during the fall or the spring. Those 7 non-native agronomic grasses outcompeted an area so much larger, a percent area so much bigger than all the other 270 plant species combined. And so that's where we're running into the problem at, is that these few non-native agronomic grasses are just outcompeting all other grasses, forbs, legumes, and everything, whether it's native or non-native. I've highlighted a few things on this slide as well. We kind of broke it down between the growth forms. The native forbs were actually very prevalent. They had a good coverage and a good presence there. Unfortunately, what I just mentioned on the previous slide, the non-native grasses, the agronomic grasses, they were so dominant. That's really all that was out there for the most part when you're talking about percent coverage, and what takes up the entire roadside is these non-native grasses. The non-native legumes, they also were very prominent mainly in the springtime. Between upland and lowland, they were both kind of similar. And then the native vines, they started coming in and having more of a presence during the study as well. But really the takeaway is the non-native grasses were just so heavily dominated, as well as these non-native legumes. Talk about their different height categories. Between lowland and upland sites, and between the different height categories, we're seeing that typically there's more vegetation in the lowland, in the low height category, something that's about 18 inches and lower. And that's where the majority of the vegetation that we're seeing. Now, you probably wonder, well, how do you get over 250% coverage when your sampling should only be equal to 100%? Well, since there's multiple species along that line transect, I decided just to leave it as a raw number and not convert anything to a percentage under 100%. And so that's why the numbers are exceed 100%. When you start talking about vegetation getting into the upper categories of the height, greater than 0.91 meters, so greater than 3 feet in height, there's not as large of a percentage of vegetation that gets to that height. And this is very important because of, once again, we're talking about roadsides. We're talking about people driving their vehicles along the highways, and you don't really want vegetation to be 3, 4, 5, 6 feet along the highway. You want to be able to see what's going on in the right-of-way. And so this basically shows that the huge percentage, about 70% of the vegetation that's out there actually grows to a low height category. This just kind of shows a little bit different spin on it. Once again, the low height category is really heavily the biggest portion of what's out there. There are vegetation that does get 3 feet high. A lot of trees and some shrubs as well are going to exceed that, that 0.91 meter height category. But for the majority of it, a lot of the vegetation is staying in that lower category, lower height category for visibility reasons as well. That's good. Once again, here's the breakdown of the analysis. We have it broke down between the seasons. There was a significant difference between seasons, as we already established. And so that's why I broke it down between the fall season and the spring season. Here, the years became a significant difference between the height categories, as well as elevation. For the most part, elevation in years and seasons were all highly significant. Once again, it's kind of a typical trend that we found with the previous data, the treatment, the 3 different treatments. We found that there were no significant differences among the 3 different treatments. So that's repeated mowing versus mow only 1 time a year, and then mow only 1 time per year with supplemental wildflower seeding. And so that's a really interesting thing that we're finding so far. Talk briefly about the woody stem densities. You have, trees like your oaks, even poison ivy was very common along the highway, wisteria, eastern baccharis, your smilax, your greenbrier were also along the highways as well. And then I saw a lot of willows, black willow trees as well. Here is just a short list of about 44 common woody plants that, that were common along the highway. And to kind of break down their woody stem density, so I used that 1/2 meter to the right of the line transects while I was sampling and collecting data. And that's how I was able to generate the stems per hectare. Every time I found a woody stem, I would identify it, I would get its height, I would get its percent cover, but I would also find out how many stems are there. If, for example, a lot of your blackberries They were cut and mowed repeatedly. And so over time, they could produce multiple stems, multiple vines. And so that was one thing that I calculated. Same thing with trees. Once a tree is cut, it'll end up doing root sprouts, and it'll have multiple little saplings and things that come off. And so each one of those were counted, and that's what we're seeing right here. The natives, no surprise, the native woody stems were the dominant ones out there. Just like the species richness, the natives are dominating the landscape out there. The non-natives aren't really dominating the area, but they do have a little presence as well. No real trend between upland versus lowland and between the different treatments or between the years as well. Just with mowing one time per year, I separated the 10 most common dominant woody plant species. And from year 1 to year 2, by only mowing one time in those 2 treatment sites, the 2 treatment subplots, you're able to obviously see a trend of a lot of these woody plants are almost doubling their area, doubling their woody stem density, doubling their percent coverage. And so it's a kind of a typical trend that you see a lot of the trees and shrubs almost doubling or having more growth by that second year when you reduce the mowing, which is expected to see. The neat thing about this chart, about this figure, is the vines. The vines show a drastic, like doubling and almost tripling in some cases of their stem density. The vines don't really impede vision as far as like driving down the highway. You're not going to have a problem with vines obstructing your vision when you're driving and you're looking at the roadsides, or you potentially see something along the roadsides like a deer or some kind of wildlife. So the vines was kind of a surprise to us, but it's really good that vines are not interfering with our vision. I didn't find any significant differences with the woody plant stem densities, but I did highlight a few that were kind of trending in a predicted direction that we had at an alpha level 0.05. And so no significant differences with the woody stem density, but just something that looked like it was potentially having some kind of predicted direction. Now, these wetland indicator species, I mentioned about a 33% were detected and categorized along the roadsides. And what I'm meaning, I'm talking specifically about the obligate wetland plants, the OBLs, which almost always occur in the wetlands, as well as the facultative wetland plants, the FACWs, which usually always occur in wetlands, but may not always be in the wetlands themselves. This was taken from Reed 1988 and Tiener 1993. So this is really what I'm looking at, is the obligate and the fac-wet categories. I could have included the facultative, but for the most part, facultatives will grow in dry areas and wet areas, and so they're not really wetland indicator species. Of the 277 plant species recorded along the highway, over 84 were considered specifically wetland indicator plants. That's the fac-wet and the obligate species. About 21% were fac-wet, and about almost 9.5% were obligate. So that basically shows that almost a third of the plant species recorded along the highway are wetland indicator species. And these next 2 slides are just kind of showing exactly what they were, in case anybody wanted to look back and see that a lot of these are fac-wet and obligate for the region that they grew in. So kind of concluding some of this stuff, we recorded over 277 native and non-native plant species in Mississippi within the United States. Almost a third of the plant species were wetland indicators. There was presence of water in many of these ditches and lowland areas. And I feel that there can be some connectivity to wetlands from the road ditches. They may not always have water. but they still represent a wetland ecosystem. And with a lot of these ditches and wetland-like areas right beside the right-of-ways, right beside the roads, a lot of these actually do connect to nearby navigable waters of the United States. Wetland wildlife species have been observed using and successfully raising offspring in what I call these roadside wetlands. And that's mainly all due to all the disturbance that's been happening. The native forbs and native grasses increased over the 2.5 year study. You can see anywhere from 3 to almost up to 5 times of an increase of these grasses and forbs. The height of the vegetation did not differ between the treatments, which was kind of surprising. And there was no treatment effect detected on the woody plant stems as well. These roadside right-of-way wetlands, as mentioned before, they're strips of right-of-ways, ditches that are basically morphing into wetland ecosystems because of the road development, because of reduced mowing practices, because of roadside construction. A lot of bridges are being put in and modified and updated, and so this is actually helping and enhancing wetland ecosystems. And there's also some research, not a lot, but there's some that shows that it can actually, or should potentially be regulated under the Wetland Clean Water Act, Section 404, and those are the two citations that are really focusing on roadside wetlands. Teener 1993 and Cooper et al. In 2019. Just to kind of finish up the discussion, non-native agronomic grasses comprised of less than 5% of the total species detected, but they dominated over 90% of the coverage in all treatments over the study period. This is good, by the way. Even though I'm all for natives and native habitat, these agronomic grasses are great for erosion stabilization and for ground cover. So I'm not trying to diss on the non-natives by any means. We did find that mowing once per season, or once per year, I mean, it greatly improved the native wildflowers and native grasses, especially in the lowland riparian wetland sites. And this had no compromise of the agronomic grasses, which the agronomic grasses are very good for erosion control. The woody stem densities and even the height of the vegetation did not increase in the reduced mowed subplots because they're going to be mowed once a year. So even if the trees do get really tall, they're going to be mowed down once a year. And obviously this is a big concern for a lot of Department of Transportation's and also for motorist visibility. The importance to a lot of Department of Transportations, the DOTs, we found no significant between the treatments. So really, why mow so often? This can also have a lot of huge cost savings. In some studies in the past, they found up to almost 70% cost savings from going to a multiple mowings 3, 4, 5, 6 times per growing season to only 1 time per year. And a big positive thing by reducing the mowing along the highways is you're enhancing native plant communities, and specifically in these lowland wetland sites, because you can't really, the mowers can't always get into these wet sites to actually mow, and so it's improving even wetland habitat. This is a proactive management recommendation. It does save money while improving the roadside beauty. These benefits can be accomplished without reducing roadside visibility. The berms, the intersections, and even the crossroads will still continually be mowed multiple times a year, mainly for visibility and safety concerns, but this is only within the first 15 meters of the roadside edge itself. We're advocating beyond that 15-meter part should be only mowed once a year. One really big support of roadside wetlands is Cooper et al. 2019, a very recent study that came out from the United Kingdom. This actually provides the first quantitative evidence of the effectiveness of constructed roadside wetlands. Basically, their results showed that wetlands can prevent large volumes of nutrients and sediments and organic matter from entering into the river network and help minimize detrimental impacts of water pollution. Obviously, there's more work to be done, mainly worldwide, about sampling more wetland-like sites and wetland areas like these roadside wetlands. Look at different physiographic regions, have longer duration of the studies, and then also look at different treatment options, maybe add herbicide in there, maybe even some fire, and even different seeding techniques as well. There's definitely a lot of people to thank. I know I'm just about out of time, but I definitely want to thank the Mississippi Department of Transportation, MDOT, also Mississippi State University for the collaboration and the teamwork, all my colleagues with the Roadside team, Dr. Jeannie Jones, Dr. John Guyton, Dr. Bronson Strickland, and even Dr. Eric Dibble. And then finally, Dr. Ray Igley with all his help with the statistics. And we just thank you so much for all the opportunity to speak on roadside wetlands. And with that, I'll turn it back over to Roy. Thank you.
Thank you for that excellent presentation, Edward. I'm assuming that you can hear me, correct? My audio is back on?
Yes.
So thank you again for an excellent presentation, which I know I enjoyed, and I'm sure all our participants enjoyed as well. I wanted to comment before we get to questions and answers that if somebody left before we got to Q&A, they could email based on the email address you provided, or if you think of a question later, you can email Edward directly. So the first question is, should the roadside right-of-ways, wetland strips be jurisdictionally regulated by the Clean Water Act as wetlands? And depending on how you answer that question, I'd like to know your perspective as to whether or not, if it is something that's jurisdictionally regulated or should be, could this not be something looked at as a way to get mitigation credits for highways in the United States?
Yes, that's a very good question. Yes, I feel that roadside right-of-ways, these wetland strips, should be jurisdictionally regulated. First of all, as my study showed, there was almost 33% of roadside vegetation was actually obligate or FAC wet wetland indicator species. There was also presence of water, which is another important factor. And then also these strips are in many cases connected to nearby streams, creeks, and even larger river systems. And so obviously some of them are not. Some of these ditches and roadsides are not connected to U.S. waters, navigable waters. But yes, I think that there could be a way to mitigate these and to get credit. Yes, most definitely.
Okay. A follow-up question. Can you talk to when these wetlands become regulated by ACOE? I'm assuming that is Army Corps of Engineers, which is the agency that I work for. That is kind of a good follow-on question to what we just talked about. I don't know if you want to further elaborate as to when wetlands become regulated by ACOE, and that's when they are jurisdictional wetlands.
I should know more about that. I can try to get back to that person that that asked that good question. Yeah, the Army Corps of Engineers definitely regulates what is considered a wetland and what's not. There's definitely 3 parameters that are considered that consider a wetland. Definitely the vegetation, the soil as well, and then even also the presence of water. And so those 3 characteristics are what can consider a wetland to be a wetland. But yeah, I'll have to try to get back on that person's question.
Okay, we have time for a few more questions because we're approaching 2 o'clock Eastern Standard Time. Another question is, were there any significant differences in the species that were wetland indicators, example, between treatments?
I did not find any differences. Just like the mowing, the different treatment mowings, there wasn't any differences there. There wasn't any difference between the just lost my words. But basically, the answer was no. There was no significant differences between those wetland indicators.
Okay. And next question, can you comment on willow prevalence in the difference between mowing treatments and elevations?
Yeah, so first of all, willow, either whether it's black willow, it is a wetland indicator. They're typically going to be found in more moist or kind of obligate or fact wet areas. Those trees are typically, you're not going to find them up in the upland areas. You're not going to find them growing on a bank side, but they usually prefer that very moist soil, that lowland area. And that's really where willow is going to be located at.
Okay, very good. I'm going to take one more question given the time that we have left. Since non-native grasses are the dominant cover, could there be a selective herbicide to treat monocytes and allow other taxa to flourish?
Yes, I didn't look at herbicides, but yes, there are specific herbicides, selective herbicides that are used for treating grasses, the monocots, and that does help basically allow the other ones to flourish. Once again, if you're either having soil disturbance or you're mowing so much or you even use herbicide, there's always that potential for invasive plants to come in and try to get reestablished or try to get established at that point. But yes, there are certain herbicides out there. I'm not an expert on the herbicide aspect, but I do have some literature if they needed it to kind of help them out with their roadsides. Yep.
Okay, excellent. I want to remind all of our participants again that you can ask questions after we leave the webinar for today. So if you do have additional questions, feel free to contact Edward directly. And Edward, I wanted to thank you again on behalf of SWS, because people that donate their time generously and share their information the way you have done today leads to the success of this webinar program that SWS cares about very much. So thank you again for your time today.
Thank you.
You're welcome. I'd like to advance to the next slide. I'm going to do some wrap-up administrative things at the moment. Here we go. Our next SWS free webinar will be held on July 16th, 2020, and will be presented by our 2019 Wetland Ambassador, Priyanka Sarkar from Assam University in India, and her mentor, Elizabeth Watson from Drexel University in Philadelphia, Pennsylvania, who will be presenting their work on carbon sequestration, nitrogen and phosphorus dynamics in wetlands, assessing regulatory service, water purification potential of wetlands, and provisioning services, wetland goods, of wetlands, economic value of wetland ecosystems. Next slide. There we go. Our next Spanish SWS webinar will be held on June 24th, 2020, and will be presented by Brigida van Tussenbrock and Ricardo Wong from the National Autonomous University of Mexico, speaking about zoobentophily. As a reminder, all the Spanish webinars are offered free of charge to members and non-members alike. And finally, be sure to subscribe or follow SWS social media channels like Facebook and LinkedIn to keep informed about support for Wetland Society. We also have a YouTube channel where all of our webinars are posted 3 months after the original broadcast with multilingual subtitles. And next slide. There we go. Thank you. And I'm not sure if we're on the right slide, but newly added to our Wetland Interviews, one in English, one in Spanish, posted to YouTube page. So that's the Wetland Interviews. You can quickly link to those on the SWS website under the Resources tab and select Wetland Interviews. If you are Spanish speaking, be certain to subscribe to Latin American and Caribbean region's Facebook page, and the links are listed here. That's why I don't think we're on the correct slide. Thanks again to Edward for his presentation, to our webinar sponsors, and thank you to our audience for your time and participation today. Have a great day and stay safe. Thank you again.